Hi guys, hope you've been enjoying the random walk on the number line by a lonely mathematician, an introduction to counting. Let's go over this thing, shall we? So what is meant to happen here is a simulation of flipping a coin and what happens and where you would end up and how many ways there are to end up at those places, thus allowing us to calculate probabilities using the number line. So if we just flip the coin a single time and we establish heads is a move to the left and tails is a move to the right, you can see that there's only two options. We could flip a head, move one place to the left, flip a tail, move one place to the right, giving us two places that we could possibly land, and those places are -1 and 1. Do we have an equal chance of ending up at each? Of course we do, if it's a fair coin. And that is a key word there. A fair coin means it is equally likely to land on heads or tails. So yes, we do. Okay, well that was easy enough. I think you can probably see, it doesn't ask you here, but the probability of landing at -1 or 1 are both 1/2. There's only two options, and both are equally likely. So landing on -1 is, the probability of landing on -1 is 1/2, and the probability of landing on 1 is 1/2. All right, well, let's increase the complexity a little bit. We're in the same place, standing on 0. This time we're going to flip the coin twice. Same rules apply. Heads is one move to the left and tails is one move to the right. So let's play out our options here. If we flip a heads twice, we'd land at -2. If we flipped a tails twice, we'd end up at 2. If we flipped, let me erase those two. So we know that -2 and 2 are both options, and there's only one way to get to those two places. Oops. Let me go back, put those back, and grab the eraser here. Get rid of these so we can see our jumps happen. All right. What else could we do? We could jump one head and then back to one tail. Or we could do one tail and back to one head, and that would be two ways to get to 0. And those are all our options. So can you end up at 0? Yes. And there are two ways. Can you end up at -1? No. Can you end up at -2? Yes. One way. And you could end up at 2, and there's one way to get there as well. So now thinking about those ways, but to calculate probabilities. So how many things could happen? Well, we could land at -2, and there's one way. We could land at 0, there's two ways. And we could land at 2, and there's one way. That's 4 possible outcomes. So the number of ways to get to each number out of all the outcomes is the probability of landing at that spot. So the probability you end up at -2 is 1 out of the 4 possible ways. 0 is 2 out of the 4 possible ways. 2 is 1 out of the 4 possible ways. -1 is 0 out of the 4 possible ways. And what is the probability you end up at -2, 0, or 2, keyword being or, is 4 out of 4 or 1. It is absolutely 100% guaranteed to happen that you will end up at -2 or 0 or 2. And that's important in our later studies of probability of the word or. All right, well, let's up the ante again. Let's do 3 flips. Okay, well, if I do 3 heads in a row, I'll end up at -3, and of course 3 tails in a row will end up at 3. So I know there's one way to end up at both -3 and 3. Let's see, what else can happen? Oh, darn it. Need that eraser again. Here we go. What else can happen? Well, we could get 2 heads and then a tail. That'll put us at -1. We could get 2 tails and then a head. That'll put us at 1. Or we could get 1 head and then 2 tails, putting us at 1 again. And we could get 1 tail and 2 heads, putting us at -1 again. We could get 1 head, 1 tail, 1 head, putting us at -1 again, or we could get 1 tail, 1 head, 1 tail, putting us at -1 a third way. So -1 and 1 have 3 ways to get to them. And the total of these ways is 8. So there are 8 possible outcomes for flipping a coin 3 times in terms of where we would land on the number line. Given that information, since there's only one way to land on -3 and there's 8 possible things that could happen, the probability of landing on -3 is 1/8, which will be the same for 3. And since there's 3 ways to land at -1 and 8 possibilities, it's 3/8, and same for 1. And these should always add to 1. All the possible probabilities would add to 1, of course. Okay, moving on. 4 times. So let's do a quick review, actually. The possible outcomes with 1 flip was 2. The possible outcomes with 2 flips was 4. The possible outcomes with 3 flips is 8. You might be able to see the pattern at this point. Let's do 4 flips and see what happens. So we know that we can get the same thing 4 times in a row and end up at the number on the number line that corresponds to the number of flips. So we could get 4 tails, we could get 4 heads. So we know that -4 and 4 are possible outcomes, and those have 1 way to do it. All right. What are our other potentials? We could get heads, 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 tails, and end up at -2. We could get tails, 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 heads, and end up at 2. So we know that -2 and 2 are possibilities. Let's see if there's any other way to get to those. How about, sorry, let me erase these arrows so we don't get confused. How about if we get a heads, tails, heads, heads? There's another way to do it. Or we could get a tails, heads, tails, tails. There's another way to get to 2. And I don't think there's any others. We could get a heads, 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 tails, but we did that one already. We get a heads, tails, heads, tails. Oh, there's another way. Ooh, let me back that up. So 2 ways to get to 2, 2 ways to get to -2. So we could have a heads, tails, heads, heads. Or a tails, heads, tails, tails. So let's see, any other ways? We've got 3 ways to get to 2 and -2 thus far. Let's try heads, or sorry, tails, 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 heads. Or heads, 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 tails. There's 4 ways to get the -2 and 2. And if I did that one before, I'm sorry, I am overwriting something I did before because I forgot there should be 4 ways. So I may have rushed ahead a little bit. If I did count that one already, I am sorry, but I promise you there are 4 ways to get to 2 and -2. So let's move on to any other possibilities. are there any other possibilities for where we could land on the number line when we flip 4 times? And the answer is yes. Let's see. If I start at 0, I could get a heads, heads, tails, tails, thus ending up back at 0. And of course, a tails, tails, heads, heads would produce the same result. There's 2. I could do a heads, a tails, heads, tails, heads. So third way, I could do a heads, tails, heads, tails. There's a 4th way. Clean this up a little bit. I feel like there's more. How about a heads, tails, tails, heads, and a tails, heads, heads, tails. And there's 2 more ways. So 0 actually has 6 ways to get there. And so this total possible outcomes is 16. We did go from 2 with 1 flip, 4 with 2 flips, 8 for 3 flips, and 16 for 4 flips. And if we kept going, we'd keep increasing by powers of 2. So this will allow us to compute the probabilities. The probability of landing on -4 with 4 flips is 1 out of 16. Same goes for 4. The probability of landing on -2 is 4 out of 16. Same goes for 2. And there's 10/16 of our total outcomes, and 6/16 is the probability of landing on 0, which would make all of our possible probabilities. Okay, moving on. Here we have the beauty of Pascal's triangle. What we've just done is demonstrated nicely in the triangle before you. As you saw from the video, it's got lots of other applications, but we are going to use it primarily to determine binomial probabilities, or the probability of some number of occurrences happening out of some number of equally likely events. So remember from the video that the first row is 2 to the 0 power. 2 to the 0, like any number to the 0, is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16, and so on. So if I am in the 4th row here, remember the first row is really the 0th row. The 4th row has a sum of 32, and like we just did the 4 flips of the coin, the one on the left or right, doesn't matter if you start on the left or the right, but if you start on the left, that number represents the probability of landing on -4 or 4, which means you got 4 heads or 4 tails in a row. That probability is 1 out of 32. This one represents getting 1 head or 1 tail. One head or 1 tail. So there's 4 ways to do that. You could get a head, tail, tail, tail. You get a tail, head, tail, tail. Tail, tail, head, tail. Tail, 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 head. That represents 4 of the 32 possible outcomes. This probability represents getting 2 heads or 2 tails, and there's 6 ways to do that. I'm not going to list them all, but you could get heads, heads, tail, tail, heads, tail, and so on. This probability is getting 3 heads. It's getting lower now because we're flipping the coin 4 times, and 3 of those were heads. So we're back down to a lower probability. There's only 4 ways to do that. And then getting all heads, and like I said, or all tails, it doesn't matter where you start, is as equally unlikely as getting no heads, which is all tails. So that's how we use Pascal's triangle to correspond to probabilities. If you wanted to continue with Pascal's triangle, you simply start with 1s on the sides and then add the 2 numbers above. And this would take us out to the 5th row. Oh my gosh, I messed up all the the 5th row is actually 32 possible outcomes. I was a row ahead before, guys. Let me do a quick erase. Come on, eraser. All of these should be 16. Sorry about that. There's 16 outcomes. Erase from your memory what you just saw. There we go. The 5th row actually sums to 32, and you can go as far as you want with this. This row sums to 64, and so on and so forth. Sorry for the long video. Hopefully you enjoy Pascal's triangle. And if you don't get to the another piece of information on Pascal's triangle, we'll do that tomorrow, okay? Have a good one.